Today, we're going to start with 1-6, which is absolute value, and solving absolute values with inequalities. Okay? So, 1-6, let's start with something very basic, just so we understand what it means. Okay, what does this mean? It says absolute value of x equals 4. What does the definition of absolute value mean? Okay, so it does mean that it equals negative or positive. Can anybody give me a better reasoning why it equals negative or positive? Go ahead. I know. Okay, exactly. How far away, we could also say it's a distance, right? It is a distance away from 0. So right now, if I'm on here, here's 0. It says my distance is 4 units away from that. So we're 1, 2, 3, 4. Hence, one solution would be at 4, right? And one solution can be at -4, because both of these have that. Oops, sorry. That is a distance of 4, as is this. Can distance ever be negative? No, there's no such thing as a negative distance. Even if I'm backing up, I'm still going in a positive distance, correct? Okay, sometimes people are like, reversing things. Like, I want to go negative or backwards, right? Ferris Bueller's Day Off, trying to go in reverse, undo the miling. It doesn't work. Okay? Once again, it's a distance. Every time you see an absolute value, think of a distance. Okay? That's the big part there. So, with that being said, we can manipulate it a little bit more as well. Okay, such as, let's do this. Okay, so what does that mean? It says the distance of that absolute value, the item that's within that, is a distance of 7 away, right? Does that make sense, everyone? So when we solve this, we need to put the value inside of the absolute value equal to who? We want to know when that distance is equal to 7. And we also want to know when that distance is equal to -7. Because these are the two distances that equal 7 units, right? Right? And now you're looking for the x value that creates that distance of 7. Okay? Subtract the 1. So therefore, one value is 2. Okay, once again, we could always check it if we needed to. I'm going to go ahead and plug the -8/3 in. 3 times -8/3 is -8. -8 plus 1, -7. The absolute value of -7, or the distance of -7, is 7 units away from 0, correct? So it does check. Plugging in 2. 3 times 2, 6. 6 plus 1, 7. 7 is 7 units away from 0, so therefore it does check. Okay? The key thing when you solve for an absolute value is you always want to get the absolute value by itself. Okay? Because my next solution is going to go ahead and be a problem that you have to do a little work before you can do the absolute value work. Does that make sense? Right now, I have the absolute value by itself. And when you get it by itself, that's when you can set it equal to the positive and negative. Okay? Okay, to go on. So if you'll notice, this has items outside the absolute value. So my goal here is to get the absolute value by itself first. And then after that, then I can actually work on the absolute value. What's our first process to get the absolute value by itself? Add the 3 over. Right? Yep. Okay. Now, this is exactly the same spot as the previous example. I have an absolute value equaling a number, correct? Okay. So because I have an absolute value equaling a number, I say, okay, once again, what is this word? It's a distance of 4. When does this equal a distance of 4? Well, my distance of 4 is when I'm going to be at 4 and when I'm at -4. Those are both distances of 4, correct? And I think if we say the word distance, it will help us more when we start doing the inequalities, because that's a little bit more interesting than these items. Okay, really quickly, subtract the 4, so x is 0. Did you see that? Subtract the 4. Subtract the 4 here, what do we get? -8. Okay. Any questions on those? Pretty simple, right? Not too shabby. Okay. Oh, absolutely, yeah. I like that. Okay, is our absolute value by itself? Nope, we need to maneuver it, correct? So therefore, subtract the 4. Okay? Three x plus 2, the absolute value of it equals -2. So what is that saying? It says the distance equals -2. So what do? Then equals a -2 and 2, right? You're giving me a dirty look. Why? I'm done already. Can a distance ever equal a negative value? So this is no solution. Okay? Because that's why I like to say the distance. Because if not, if you're just doing math, and you're like, oh, I just said equal to the positive, I said equal to negative. Okay, sometimes that's what caught you was when I said the word the distance, right? If I just jumped up there and did 3x plus 2 equals -2 and 3x plus 2 equals 2, you think you would have caught that. Hence why I like to, every time I see this, the distance equals -2, okay? So therefore, you're saying to yourself out loud what's happening, and maybe you can catch it. But if not, let me just show you really quickly. 3x plus 2. What if you didn't catch yourself? I'm going to show you that it'll still work. All right, here we go. So I'd subtract the 2, so I'm at 3x equals -4, or x equals -4 thirds. Let me plug it in for you. -4 thirds times 3 is -4. Negative 4 plus 2 is negative 2. What's the absolute value of negative 2? 2. Does 2 equal negative 2? So therefore that solution doesn't work. Okay? Go ahead and put this over. I subtract the 2. 3x equals 0, or x equals 0. I plug it in. X times 0 times 3. 0, 0 plus 2. 2. Absolute value of 2 does not equal negative 2, does it? So neither of those solutions work, correct? So therefore, hence, it doesn't. So basically all you got to do is ask yourself, is a distance ever equal to a negative number? Okay? Does that make sense? Any questions with those? Do you think we're okay with that part? Get on to the inequalities. Okay? Because inequalities, you have to reason yourself a little bit more. So, absolute value of x is greater than 4. This kind of makes this an or statement. We're looking for the regions that will work to make this happen. Because once again, anytime I have an inequality, there's an infinite amount of solutions, isn't there? Because anything that puts that value in that's greater than 4 will work. Give me a solution just off the top of your head. 5. Absolute value of 5 is greater than 4. There's a solution. As you just said, 6 is another solution. There's many or infinite. Okay? But what is this saying? This is saying the distance has to be greater than 4. Correct? So I'm going to push pause. I want you guys to use a little critical thinking skills. And on your number line, okay, here's 0. I'd like you guys to go ahead and think about, shading-wise, what distances are greater than 4 away from 0. Okay? So take a couple, maybe a minute, and do so. Okay, tell me your name, bud, with the W hat. Kyler. Okay, as Kyler already brought up, he brought up a solution that was larger than 4. Here's 4. What's the solution larger than 4? He brought up 5. You, Landon, brought up 6 as well. So we already know that this side, those are distances greater than 4, correct? Okay, once again, open or close dot? Open dot, right? Okay. How about, is that the only distance is greater than 4? We have this as well, right? Here's negative 4. Is negative 5 a distance greater than 4? It is. Because if you take the absolute value, once again, the distance is how far away, right? Even though it's on our negative side of our number line, it's still distance of 5. Correct? So here's negative 4. Negative 5 would be here. That would be a distance of 5. Is 5 greater than 4? So therefore, I have to also say to myself, these guys over here are also distances greater than 4. Okay? So how can I write this, ladies and gentlemen? What's this one saying? This inequality is saying x has to be greater than 4, right? What about this one? X has to be less than negative 4. Okay? So, notice this would also be an or statement. So, for my set builder notation, if that's what they're asking us, I would do x such that x is less than negative 4, or x is greater than 4. Okay? What would be our interval notation? How far left do we start? We start at negative infinity. We stop at negative 4. Union, we go from 4 to infinity. Meaning, any number within these ranges should work for our absolute value equation inequality. Correct? Yes, Landon. Okay. So, how would I technically solve this straight out of the get-go? So if I had this, absolute value of x is greater than 4, okay, I'm going to quickly just say, okay, x is greater than 4, or x is less than negative 4. Notice I switched my sign down to here, right? Okay, makes sense? Any questions there? Just set them equal to 2 equations. That was a very simple one. So let's go ahead and do a little bit more enticing one, a little bit more intriguing. So we're saying, all right, we have negative 4x minus 3 is greater than or equal to 5, because that's saying we want a distance greater than 5, right? Makes sense? Once again, little scale for you. Here's 5. Those are numbers greater than 5 is that side, right? We also want things negative 5. So we want things on that side of it. Okay? Now this isn't my solution, but this kind of helps us determine why negative 4x minus 3 has to be less than or equal to negative 5, because we want values for that side, correct? Those things, because those are still distances, that would be greater than 5 in general. Okay, once again, me using the word distance can kind of help see the picture a little bit better here. Quickly going to go ahead and add 3. Have negative 4x is greater than or equal to 8. What happens here though? We're going to be dividing by negatives. So what does that do? We flip our sign. How about your name? Alex, thank you. Negative 2. Okay. Go ahead and add 3. Negative 2 divided by negative 4 would be a half, wouldn't it? Okay. So now, we need to go ahead and use our number line just to kind of get a general idea. Here's 0, here's a half, here's negative 2. Looking up here, it's saying x is less than negative 2. So that's all these is openers closed. Close. Make sure you have the arrow to continue it on. And then the other one's saying x is greater than or equal to a half. Okay. That would be the graphing solution, right? What would be the set builder again? How do I do set builders? You just look at these and say, okay, basically these ideas, right? So x such that x is less than or equal to negative 2. What word are we going to use? Because we have more than one. We're looking for or. X is greater than or equal to a half. What would be our interval notation? Hopefully I'm not going too fast, guys. I'm not trying to. So if I am, please slow me down. Okay. What would be our interval? How far left do we start? Negative infinity. How far do we go? So -2 when we stop. Is it a bracket or a parenthesis? Bracket because of the include, and remember, negative infinity can never be included because we can never touch negative infinity, can we? Or infinity. Union that with, where do we start back up again? A half to infinity. Okay. Any questions? Yes, ma'am.
Can you go over another question like this?
More than welcome. Does it have to be, can I switch it up just a little bit, or do you want
Yeah,
something
this
just,
is
okay.
good.
Right. Okay, so once again, I always start off with every problem. I read it to myself in a way. Basically, I'm saying this distance has to be what? Less than 2. And anytime I have an absolute value, I have how many equations? 2. Because I got to say it's equal to a positive amount and a negative amount, correct? That makes sense. But anytime I have an inequality, I kind of want to just do a basic sketch of just saying, all right, here's 0, here's 2. That's a distance less than 2 is in here, huh? Make sense? What else, though? What about on the negative number line? How far away can I go? -2, and notice once again, this information is a distance. So what does this whole stuff have to be? It has to be between -2 and 2. Does that make sense? So whenever I have a less than, what I do is I just go like such. I make it into an and statement. Can you guys see how that's an and statement between two numbers? So it's less than 2, but it's also greater than -2. You guys see how that information is correct here. Our stuff, our distances, are between 2 and -2. Hence why I went ahead and wrote it as a and statement. You see how that little left picture over on the side can help us dictate where it's in between? Whereas in the previous problem, really quickly, notice how we had 2 distances on the outside, hence I have 2 different equations with going in opposite directions, right? You see how this can help us a little bit? Brett. So always, like, I could even do this right here, Greg. Y minus 5 is less than 2, but because of what it is, knowing that it's in between 2 numbers, I know it's the word and, right? Y minus 5 has to be greater than negative. So switch the sign and the number. Good question. Everybody there with us? But once again, I prefer to solve it in this form, just because, once again, less writing purposes, right? So I'm going to add 5 to basically both sides, all 3 sides technically, right? Because this is technically an equation if I got rid of this, right? Here's an equation if I get rid of this stuff over here. And like I said, most of you guys have seen these things as review, right? This is a review idea. With that being said, you guys should remember what this minus 5 does to any graph. Remember, we have an absolute value graph, which looks like a V, if you recall. You guys remember shifting? What does that minus 5 do? It shifts it to the right, because this is on the inside of the function. If it was on the outside of the function, it would shift it up and down. But because the shift is on the inside of the function, you shift it opposite of what we see. So So we're here, we shift everything over right 5. So if I shift this value over right 5, that's why it's at 7. If I shift this value over right 5, so notice 2 plus 5 is the 7. Negative 2 plus the 5 is 3. Hence it just shifted that whole solution set over to the right 5. Then you guys remember shifting, just basic graph, last year up, down. I think that's basically what you did. You guys might have compressed them and made them tighter or wider, right? But once again, this would be our set builder notation. How do I write this as set builder? We don't use x's this time because we have a y, so therefore it's y such that we need to go ahead and graph that. Here's 0, here's 3, here's 7. Your open dots with that stuff in between. Okay, that's perfect. Okay, what would be our interval notation? Anyone volunteer for that? Shout it out for me. 3 to 7 with correct, right? I need one of those long ones. It'll be done in like 15 minutes in my house. Got my windows closed just so I don't get distracted. Yes. Sure can. Okay. Any questions there? Was that a little slower for you? It's in between. Notice that's the stuff that would work. It's in between. Okay. Oh, I forgot one of these ones back in the day. Hold on. We'll come back. This one's not an inequality. This is an equal sign, but notice we have, once again, an absolute value equaling another absolute value. All right. So when you're doing an absolute value equals another absolute value, you still want to kind of think about it in treating this as just one. So we're going to keep one of them side just regular. You're not going to switch it at all. Okay? So keep him as 3x plus 2. But then you're going to equal when this guy is equal to him as well. We're not going to change him at all because think about it saying, when does 4 equal 4? In here, right? Does that make sense? Like, let's go over here just a little bit. If I had the absolute value equals absolute value of 4, what other solution could I have? That works. The absolute value of 4 equals the absolute value of 4. You guys agree with me? What's another type of solution that I could have? Absolute value of 4 equals absolute value of negative 4, right? You guys agree with me? So basically, once again, I keep this guy the same and then do the opposite on the other side, right? Does that make sense to everybody? So I have one where it keeps it exactly the same and one that is opposite. How do we do an opposite? You negate the whole thing. Because if you look at this, this is kind of like 4 equals 4, right? And this is saying 4 equals negative 4. See how I negated the whole process of it? Right? Okay, so really quickly, I'm going to get x's on this side, so I'm going to subtract, and I'm going to subtract 2. Everybody see what I did there? Got everything with a number on the right side, everything with a variable onto the left side. Yes? Yes? So one of our solutions is -7. Okay, this one I have a little work first to do. Distribute them through. Combine like terms. I'm going to add 2x and subtract the 2. So x equals 3/5. That's my 2 solution. Very similar to what we did in the past, except instead of equaling it like to 4 and -4, I have to equal to its operation and its opposite. Pretty good there. I'm going to let you write that one down already. A lot of curl things. I don't have any curls. They don't come out. You give me some? That's so nice. We good? Hippy hoppy, hey? Okay, let's do another one. Another inequality. I really like 3x plus 1. Whoa, what does that say? Okay, what can we say instead of the absolute value? What's another word we can use? The distance, right? What is that saying? The distance is greater than -2. Isn't our distance always going to be greater than a negative number? Not no solution. It's an infinite solution. Why is this infinite solutions? Because it doesn't matter what I plug in here, does it? Because when I take the absolute value of it, it's always going to be at least greater than, or 0 or greater, isn't it? Does everybody agree with me on that? No matter what comes out of here, it's always going to be bigger than 0, isn't it? 0 or bigger, I should say. So therefore, isn't that always bigger than the -2? So therefore, once again, the word distance can maybe help us understand that this is always going to be greater than -2. So therefore, on a number line, here's 0. How would I graph all solutions or infinite solutions? Right? That'd be our infinite solutions. Because pick any number in the whole world. Yes, ma'am. Exactly. Because this is, if this was 2, would there be infinite solutions? No. Well, yes, technically yes. Meaning, because I guess absolute values always with inequalities always have infinite solutions, right? But this solution is all real numbers. Anything I can plug in here will always work. Yes, sir. Okay, so let me get you another one. So if it was equal to, that's a no solution, right? That's never going to happen. Correct? Yeah. But because it was a greater than or equal to, that means that I will always have any number I plug in there will always work. Okay, so think about what that means in general. Okay, when an absolute value is equal to negative, does that ever happen? No, never. When can an absolute value be greater than a negative number? Always. So all real numbers. Help you out there, right? Okay, so let me hurry and just finish this one up and then we'll go on to that question. That's a good part. Let me just finish up this answer. So let's hurry and write it in step builder. X such that, how are we going to write this? Belonging to all real numbers. And then interval notation. Those infinities are pretty kick-A right there, I'm telling you. Some of my better ones. Okay, so we good there? Give it a little bit of time. What time we get out of here, guys, again? Like 50? Something like that. Okay, so really quick, as Greg just brought up, what if I had the exact same equation but less than -2? Once again, if I read this out loud, okay, what could I say here? The distance is less than -2. When is that going to happen? Never, right? That'll never happen. So what is this? This is a no solution. So, just by the way, I don't think we brought this up, but this is how you'd write it in set builder. X such that X belongs to the empty set. That right there means no solution. Okay? Does that make sense to everybody? Now, is there an interval notation for no solution? There isn't. You just say no. Okay? How are we feeling? Not too bad? Pretty okay? You just see if there's anything else you really need to cover. Okay, really quick, get out your homework schedule really quick. I'm going to add a couple questions. You don't have a lot tonight, it's only one section. But... yeah, I'm not saying. If you guys will add 75 to it. Number 75 is going to add number 25. Okay, and then there was one thing that we need to cover in 1-5 again that I missed, I forgot to do. So I'd like to go back to 1-5. And if you guys will look at, you guys are going to do 11 through 16 tonight as well. 1-5, 11 through 16. Okay? Let's hear you talk about that subject really quick. So I'm going to quickly just make up my own set. Okay. So these are called sets or subsets. Okay. A has these specific numbers. B has these specific numbers within. Okay, we have two things in which we talked about, at least one of them previously. So if I said this, A, that, what does that mean? A, what did we call that already? It isn't or, but we use that as a union sign. This means union. And that is an or statement, isn't it? Okay. Now, when we say or, what does that mean? It could be in one or the other or in both, correct? Okay. So we're going to write a new set. What set would be A union B? If you'll notice, these are the odd numbers less than 10. These are the multiples of 3 less than 10. You guys see that? Okay. So, A union B. What does that mean? Not, you used the wrong word. Not and, or. So therefore, this is equal to what numbers are in A or B? What's the only number that isn't in this one that's in this one already? Well, excuse me. Let's say it again. What numbers are not in this one that are already in? Oh, hell. You guys get that 6 is the only number that's being different? I'm sorry. Okay. So what I'm going to say is my OR statement would be 1, 3, 5, 6, 7, 9. Notice everything that's in A or B, and even if they're in both, I don't rewrite them if they're in both. Okay, I only still have 1, 3, even though it's in both sets. I just write it 1. So all these numbers are in A or B, aren't they? Does that make sense to everyone? Okay, now a little bit further. Union's always an or. So this one means intersection. An intersection, if you think about it, is where they overcross, correct? If you think about a road. Okay? It's what they share. Like an and statement. And means it has to be in both. So what number or numbers are in both? 3 and 9 are in both subsets, aren't they? So 3, 9, and that would be it. Because that would mean and. Pretty self-explanatory, pretty easy solution, right? Once again, the key thing you have to understand is a union is or, an intersection is and. Okay? You guys think you can do that now? Okay, so you guys have the homework 1-6. Then I added 2 extra questions, which were 25 and 75. Am I correct by that? Okay. And then I also added 1-5, 11 through 16. Okay? Any questions on that? Once again, let's talk about testing procedure.